When you're programming, one of the biggest hurdles isn't just getting your code to work. It's making sure it doesn't break in some weird, unexpected way down the line. Today, we're going to dive into a really fundamental concept that helps keep your code organized and predictable. We're talking about variable scope. But before we even look at a single line of code, let's think about something from everyday life. Have you ever been in a room where two people have the exact same name? Maybe you've got two friends and they're both named Alex. It gets confusing, right? You shout, "Hey, Alex," and suddenly two heads turn around. You have to add a little extra info to clear things up, like, "No, Alex with the blue shirt," or "I meant Alex from work." That little bit of context makes all the difference. Well, believe it or not, your code faces this exact same dilemma. When it comes across multiple variables that share a name, it needs a clear way to know which one you're talking about at any given moment. Thankfully, programming languages have this really clever, built-in system to handle this potential chaos, and that system is called scope. It's basically a set of rules that gives every variable its own specific place to live and work. So, to really get a handle on this, let's use a simple metaphor. Think of it as a tale of two variables. I want you to imagine that your entire program, all the files and all the different parts, is one big house. It's a single structure, but it has lots of different rooms and common areas. All right, so let's start in the main part of the house, the global living room. This is where we're going to find the variables that are available for everyone to see. In programming terms, this public space is what we call the global scope. A global variable is basically any variable that's defined outside of a specific function, which means it can be seen and accessed from pretty much anywhere in your code. So, back to our house. This is the living room. It's a shared public space. If you hang a big clock on the wall in the living room, anyone, no matter what room they're in, can pop their head out and see what time it is. But of course, a house isn't just one giant living room. It also has private spaces. And this brings us to the idea of a private local room, where variables are kept separate and to themselves. And this is what we call local scope. A local variable is one that you declare inside a function. And here's the key part. It can only be seen and used by the code that's also inside that very same function. It's essentially walled off from the rest of the house. Think of this as a private bedroom. The stuff you keep in your bedroom, your posters, your books. It's only visible when you're actually in the room. Someone standing out in the hallway has no idea what's on your nightstand. Okay, so this leads to the most important question of all. What happens when names collide? What if you have a variable in a private bedroom that has the exact same name as a variable out in the public living room? Well, programming has a very clear answer for this. It's called the rule of precedence. This slide really breaks it down perfectly. Let's go back to our clock example. You've got that big clock on the living room wall. That's your global variable. But maybe you also have a little alarm clock on your bedroom nightstand. That's your local variable. Now, if you're standing in your bedroom and you need to know the time, which one are you going to look at? You're going to look at the one that's right there next to you, right? The local one. And in programming, it's the exact same idea. The local variable always wins. It takes precedence. This brings us to a more formal way of saying it, which you'll often hear. If a local variable in a function has the same name as a global variable, the global variable is hidden from the body of the function. Now, hidden is the key word here. The global variable isn't gone. It hasn't been destroyed. It's just, it's being overshadowed by the local one that's closer. Let's look at a real example here to see this in action. What we're seeing is the output from a simple program. We've got a global variable, x, and it starts out with a value of 1. Now, one part of the code, we'll call it function b, can see that global x and it changes its value, first to 10, then to 100. But now, look at function a. It creates its own private local variable that it also calls x, and it sets that to 25. Notice how anything that happens inside function a has absolutely no effect on the global x. That local scope acts like a protective bubble, preventing any accidental changes from spilling out. So let's bring this all home. Why is this concept so important? Well, because understanding scope is really at the heart of writing clean, reliable, and predictable code. It's all about the power of having clear boundaries. So why does it matter so much? Well, for one, it prevents you from making some really disastrous mistakes. But keeping variables local, you can't accidentally mess up some critical global value from inside a totally separate part of your program. It also just keeps your code from becoming a tangled mess. It lets you write these nice, self-contained functions that you can reuse, and you don't have to worry if the variable names inside might clash with something else. All of this makes your code so much easier to understand and, when things go wrong, to debug. Really, when you boil it all down, it's this simple. Scope gives every single variable a home. Whether it's out in the public living room or tucked away in a private bedroom, each variable knows exactly where it belongs, and your program always knows which one you're talking about. And that kind of leaves us with a final thought. This idea of scope, of using clear boundaries to manage complexity and avoid confusion, it really applies to so much more than just code, doesn't it? It makes you think, in what other parts of our lives, maybe with our digital files or even our work projects, could creating clearer boundaries help us build things that are just a little more predictable and a little less chaotic? Something to think about. Thanks for joining me.